Good morning, students. Myself, Dr. Rajwant Kaur, posted at GPCG Amritsar as chemistry lecturer. So, our today's topic is fuel rating and future fuels. Now, the question arises, why fuel rating and what is fuel rating? First, we will be discussing this part and then we will take up the future fuels. Now, fuel rating is done in order to designate the quality of a fuel. Generally, in vehicles, we use two types of fuels. One is petrol or the gasoline, and the other is diesel. Now, these two fuels are used in two different types of engines. So, the requirements of the engines are different, and as a result, the properties of the fuel which are used in these two types of engines that are different. Now, first we will be discussing the fuel rating or the rating of gasoline, then we will take up that of diesel. Now, how to judge the quality of petrol? Generally, the petrol is given octane number. It is the quality of petrol is expressed in terms of octane number. Now, what is octane number? Octane number is basically an arbitrary number which varies from 0 to 100. Now, before we go deep into that, first we will have a look how the gasoline or petrol is used as a fuel in the internal combustion engine of scooters, cars and aeroplanes. Now, in internal combustion engine, during the downward stroke of the piston, the mixture of gasoline and air is sucked in and drawn into the cylinder. It's the first step in the operation of the engine. Now, when the gasoline mixture of gasoline and air is sucked in, it is then compressed. Now, upward stroke, the mixture is compressed to a small volume and then it is ignited by a spark from the spark plug. The chemical reaction results in the production of carbon dioxide and water. Now, the efficiency of the fuel in this case depends upon the extent to which it can be compressed. More the compression, better will be the results. Now, what happens is when the combustion takes place, lot of gases are produced which results in the expansion, and this expansion and the hot gases push the piston downward, thereby making the wheels move forward. So, basically we have three steps. First is that the mixture of air and gasoline is sucked in, then it is compressed and ignited. As a result of this ignition, combustion occurs which results in the expansion, and this expansion pushes the piston downward which makes the wheel move forward. So, efficiency and power of the engine in this case will depend upon the extent to which the fuel air mixture gets compressed at the time of ignition. Now, the quality of the fuel affects this compression. Now, what happens is we simply say that the compression, if the compression is greater, then the efficiency of the engine will be better. Now, what is the difference between the two categories of the fuels? The reason here is the quality is expressed on the basis of this extent. Now, what happens is sometimes increase in this compression beyond a certain limit results in pre-ignition of the fuel air mixture. Means the fuel air mixture gets ignited itself due to this compression, even before the spark is actually passed. Now, what happens due to this is irregular combustion of the fuel takes place. Now, this irregular combustion then gives violent jerks to the piston, leading to a rattling noise, metallic noise, and this is given a specific name known as knocking. Now, due to this knocking, the efficiency or the power of the engine gets reduced, and in addition it causes damage to the piston as well as the cylinder of the engine. Now, there are certain ingredients which are added to the fuel in order to reduce this knocking. Now, this knocking basically depends upon the quality of the fuel. A better the quality of the fuel is, lesser will be the knocking. Means a better quality fuel does not get ignited on its own due to compression, and as a result does not produce knocking. Now, how to judge the quality, or how can we say that a fuel will be producing minimum knocking, or how can we say that this fuel is the best fuel? We must have a scale. Now, this scale is known as octane number. Octane number is defined as the volume, or the, if a particular fuel gives the same anti-knocking properties as a mixture of isooctane and our normal heptane. In this case, the normal heptane is given an octane number 0. The reason is normal heptane produces maximum knocking. In this scale, that is the octane number, the hydrocarbon isooctane, the IUPAC name of which is 2,2,4 trimethyl pentane, it is regarded as the ideal fuel. Why ideal fuel? Because it gives minimum knocking, and as a result it has been assigned an octane number equal to 100. On the other hand, the hydrocarbon normal heptane, having 7 carbon atoms in a straight chain, it is considered to be a very poor fuel because it gives maximum knocking, and as a result it has been assigned an octane number equal to 0. Now, the petrol is rated or graded in terms of octane number. Now, we have 2 hydrocarbons, and we have assigned one as the octane number 100 and the other as the 0. But how can we scale a given fuel, given sample of fuel between these two numbers? Now, octane number, all the other fuels that is rated between these two extreme values, that is 0 and 100, it is done by comparing the anti-knocking properties of the fuel under consideration with suitable mixtures of normal heptane and isooctane. We take a mixture of these two hydrocarbons and compare the anti-knocking properties of the fuel under consideration and this mixture. Now, if the fuel has same anti-knocking properties as our mixture of normal heptane and isooctane, then the volume or the percentage of isooctane which gives same anti-knocking properties as the fuel under consideration, that number, that volume is given as the octane number to that very fuel. Or in other words, what we do is, octane rating of a fuel is defined as the percentage of isooctane by volume in a mixture of isooctane and normal heptane, which has the same anti-knock properties as the fuel under consideration. Means we see the anti-knocking properties of the mixture as well as the fuel under consideration. If they have comparable anti-knocking properties, then we determine the percentage of isooctane by volume in that mixture. Now, this percentage by volume of isooctane in the mixture is known as the octane number of that fuel. For example, if the octane number of a given sample of petrol is 80, what does it mean? It means that it has same anti-knocking properties as a mixture of 80% isooctane and 20% normal heptane by volume, right? Now, if we say that a particular sample has anti-knocking properties of 90, that is octane number is 90, then it will mean that it has the same anti-knocking properties as a mixture containing 90% isooctane and 10% normal heptane by volume. Now, all the petrol samples which have octane number of more than 80 or more than 80, they are termed as good fuels. Now, a fuel sample or a petrol sample having an octane number less than 80 or you can say less than 79, then it will be regarded as a poor fuel. Now, more the octane number, the better is the quality of the petrol fuel. Now, no doubt we have a scale of 0 to 100, means we have two hydrocarbons, one having maximum knocking and the other having minimum knocking, and given the octane number 0 and 100 respectively. Now, recently what it has been found is that there are certain fuels which are better than isooctane and worse than normal heptane, means they have anti-knocking properties better than isooctane, and as such, if they have better anti-knocking properties than isooctane, then they will be assigned octane number greater than 100. And if they have poor, you can say they have more knocking, they show more knocking than the normal heptane, then they will be assigned octane number in negatives. Less than 0 means negative. For example, normal nonane hydrocarbon, straight chain hydrocarbon, which has 9 carbon atoms in a straight chain, it has an octane number of -45, means it is a poor fuel as compared to normal heptane. And on the other hand, 2,2,3 trimethylbutane, which is commonly known as tryptane, it has an octane number of 125. That means it is better fuel than isooctane. Now, what is the effect of the structure of the hydrocarbon, because we all know that petrol is nothing but a mixture of hydrocarbons. Now, what is the relationship between the structure of a hydrocarbon and its octane number? Now, it has been found, now these before going deep into that, have a look at the structure formulae of normal nonane and 2,2,3 trimethyl butane or tryptane. This is better than isooctane and this is worse than normal heptane. Now, how can we increase the octane number of a fuel, of a sample of gasoline? There are certain substances which are added to the fuel to improve its anti-knocking properties, but these materials which are generally used to increase the anti-knocking properties of the gasoline sample, they are very poisonous. One such compound is tetraethyl lead, or symbolized as, abbreviated as TEL, and diethyl telluride. This is the formula of diethyl telluride, C2H5 twice Te. Now, a sample of gasoline which contains tetraethyl lead as an additive for improving the anti-knocking properties of the compound, that is generally known as leaded petrol or ethyl gasoline. If it has diethyl telluride as a addendum to this gasoline sample, then it is known as ethyl gasoline. No doubt these gasoline samples will show better anti-knocking properties than the one which does not contains these substances, but the reason behind not using them today, because these days we use unleaded petrol. The reason behind is that they are highly poisonous and they cause environmental pollution, they are responsible for various diseases. So, we do not recommend to use these substances for improving the anti-knocking properties of the gasoline. Now, what is the influence or how the structure of a compound or a hydrocarbon influences the fuel quality, chemical composition or structure? In general, what we have found is that the straight chain alkanes, they have lower octane numbers than the branched chain alkanes. As we have already noted, normal heptane or normal nonane, which are straight chain alkanes, they have lower octane number, 0 and less than 0, as compared to isooctane, which is a branched chain alkane, or tryptane. Another relationship has also been found that the octane number of straight chain compounds decreases with the increase in chain length, as in the case of normal heptane and normal nonane. We have only 7 carbon atoms in a straight chain in case of normal heptane, which has been assigned 0 octane number, and we have 9 carbon atoms in a straight chain in case of normal nonane, which has been assigned an octane number of minus 45. Now, as octane number of methane is 122, which is quite higher, but that of ethane is 101. Now, if we see the relationship between the structure of methane and ethane, the only difference is that methane has only 1 carbon atom and ethane has 2 carbon atoms in a chain. Now, with increase in just 1 carbon atom, increase in the chain length by 1 carbon atom has decreased the octane number by 21 points. Now, branching of the carbon chain tends to increase the octane number of a fuel, as we have noticed in case of isooctane and normal isooctane and tryptane. If we compare the octane number of cycloalkanes with the corresponding open chain alkanes, we generally see that the cycloalkanes, they have higher octane numbers than the corresponding open chain alkanes, otherwise having the same number of carbon atoms. But in case of cycloalkanes, the two ends of the chain, they are joined together to form a ring. They have higher octane number, and if the chain is open, then they will have lower octane number. Alkenes, that is the hydrocarbons which have carbon-carbon double bonds in their molecules, and the aromatic hydrocarbons, they have higher octane number than the corresponding open chain alkanes. If we say that the corresponding open chain alkanes, we say that they are having same carbon atoms, number of carbon atoms. Now, if they have a double bond, that means they are alkenes, or they have an aromatic ring, aromatic hydrocarbons, benzene rings in their molecules, then they will have, in case of alkenes and aromatic hydrocarbons, they will have higher octane number than the corresponding open chain alkenes. Now, this is in general, we have given the order that the straight chain alkanes, they have minimum, followed by branch chain alkanes, then alkenes, cycloalkanes, and aromatic hydrocarbons, they have the highest octane numbers. Now, coming to the other category of the fuel which we generally use in our vehicles, that is diesel. Now, the quality of the diesel is given in terms of cetane number. In case of petrol, it was octane number. In case of diesel, it is cetane number. Now, the knocking characteristics of the diesel fuel, they are expressed in terms of cetane number. Now, the question arises, what is cetane number? As in the case of octane number, we have two extreme values. In this case also, we have two extreme values. But in this case, the two hydrocarbons which we compare, in this case, they are alpha methyl naphthalene, which is an aromatic hydrocarbon, and the cetane hydrocarbon, which is a straight chain hydrocarbon. And this is, when we compare cetane, which is IUPAC name having normal hexadecane, it is a saturated hydrocarbon, means carbon-carbon single bonds are there, no double or triple bond. It has a very short ignition lag, means the time which it takes as compared to any commercial diesel fuel. As a result, its cetane number is taken as 100. On the other hand, alpha methyl naphthalene, which is an aromatic hydrocarbon, it has a very long ignition lag as compared to any commercial diesel fuel. Now, as it has the long ignition lag, it is given cetane number 0. Now, in this case also, we have a scale between 0 and 100. Now, the
general structure of synthetic oils, so just like esters, polyester. Third synthetic oil is silicones. Silicones have polymeric structure with organic radicals attached to silicon atoms and are not oxidized below 200 degrees centigrade. So, at 200 degrees centigrade they does not oxidize. So, they are used for low temperature lubrication purpose. These are generally dimethyl silicones. So, third silicone oil, synthetic oil is silicones. Next is fluorocarbons. So, these are polymeric in nature and are not easily decomposed by heat, not oxidizable and chemically inert except molten sodium and potassium. These are quite expensive synthetic lubricants. Next is polyglycols and related compounds. In rubber bearings and joints, polyglycols like polyethylene glycol, polypropylene glycol and polyalkylene oxides can be used as water soluble as well as water insoluble lubricants. These are also used in roller bearings of sheet glass manufacturing. It may be noted that the polythene oxides are not used as lubricant at high temperature, as they undergo thermal decomposition at high temperature. So, these used at high temperature. Next is semi solid lubricant or greases. So, in first half we have discussed about lubricating oils. So, that was mineral oil, vegetable oils, animals oil, blended oils and synthetic oils. And now is greases, or you can say semi solid lubricants. So, they are not solid, not liquid, they are in between them, that are, so this is called semi solid, or you may say greases. The greases are, what are greases? Soap dispersed through liquid lubricating oils. So, if a soap is dispersed in liquid lubricating oil, so that will become grease. The oil may be natural petroleum or synthetic oil, or may contain some additives. So, which is the oil, lubricating oil? It may be natural petroleum or synthetic oil, in which soap is dispersed and become and it will make grease. Soap function as thickening agent, so the grease stick firmly to the metallic surface. So, what is the function of soap? It will act as thickening agent. Greases have the tendency to separate into oils and soaps. So, greases are gel, soap gelling agent, given interconnected structure containing added oil. The soap dissolved in the oil, the interconnected gel structure breaks at high temperature and the greases liquefy. The amount of added oil determines the consistency of the finished grease. So, grease have the tendency to separate into oils. So, if when the grease is formed at after some times, it will have the tendency that oils and soaps will become separate, as greases are gel, soaps are gelling agent. So, they will form a interconnected structure. So, how greases are prepared? Preparation of greases by saponification of higher fatty acid with alkali like sodium hydroxide, calcium hydroxide, etc. So, we will make ester of these bases, that is sodium acetate, just like that. These are higher fatty acid, followed by addition of hot lubricating oils, while under agitating with or inorganic thickeners like carbon black, colloidal silica, finely divided clay, etc. may also be added to improve the heat resistance of the greases. Classification of greases. So, first one is cup grease or calcium based greases. So, this is prepared by adding the desirable amount of calcium hydroxide to a hot oil with constant agitating. So, constant agitating, that is, these are emulsions of petroleum with calcium soap. So, when calcium soap is added with petroleum, so from calcium soap, what is calcium soap? That is calcium hydroxide added in a hot oil. So, this is cup grease or calcium based grease. Where it is used? It is used at the low temperature, because at high temperature the oil and calcium soap begin to separate out. So, these are used at low temperature, where the machines are used at low temperature, where the temperature of the machine does not become high. So, they are used at that temperature. The greases are called cup greases or calcium based greases. Second is a lithium based grease. In this, lithium soap is dissolved in petroleum oils. So, in first there was calcium soap, in second there is lithium soap. Lithium soap is added in petroleum oil. This is used below 15 degree centigrade and this is water resistant. So, when there is a water in the machines, so it will be used at that in that condition. This is lithium based grease. Third one is soda based greases. Sodium soaps, when sodium soap is added with petroleum oils, This is called soda based grease. This is used up to 175 degree centigrade, mainly in the ball bearings, where the lubricants get heated up due to friction. Okay. Next is axle grease. As the name indicate, it is used in axles. It is prepared by adding lime to resins and fatty oils. So these are resistant to water and are used for less delicate equipments under high load and low speeds. So at axle there is a high load and low speed.